As Mark started the program off with the background of how we got to a U.S. Drought Monitor product and how it's evolved over the years, I'm going to jump forward to, what's the process that we go through each week to make this product, and also I'm going to talk to you about how you can potentially participate in this process. So going back over time, this map says August 10th, 1934. USDA was trying to show the impact of drought to crops around the country, and this was something that they put out to try and show, where crops are poor, where water supply is low, average or above average down in the southeast, but they were really trying to do this. So you fast forward 60 years and we start talking about how the Drought Monitor came about. These efforts were out there either through the Palmer or individual drought indices, USDA looking at crop reports and crop condition reports to put something like this together. So we've been trying to do this for quite some time. So Mark covered a lot of information about how the background of the Drought Monitor came about. And as he mentioned, this is all hosted at the National Drought Mitigation Center at the University of Nebraska. We do have partners within NOAA and also within USDA. All three of us are equal partners. We come together to do this work each week, again, as Dave brought up, without a budget. Some years we'll have up to 12.5 million hits to this product, especially in a large or summertime drought period. It's used in several USDA programs, which we're here to talk about today. Mark mentioned the IRS, and many others are using this as well. You can get to it at the droughtmonitor.unl.edu. This is the launching point for where you can get into the Drought Monitor information. I know you can't read it from the back of the room, but we do have these tabs up here: maps, data, drought summary, about the U.S. Drought Monitor, current conditions and outlooks. It's more than just the map. There's a lot of information that you can get on this web page, and I highlighted some of my favorites from these drop downs that I use. And also, there's a narrative summary associated with this map that comes out. So each week when the author does the map, they make the changes, but then they also do a write-up of what changes were made, what kind of data were being looked at, what kind of impacts are being discussed, and it's done on a regional basis. So if you're only interested in the Southern Plains, you can go and pull up that area, read about those changes, look at the map, and then you can say, okay, I kind of understand what that author was trying to do that week. Also in that summary, we give a little bit of a forecast. We do look out about 2 weeks based on the information coming from the Climate Prediction Center to give an idea of where we're anticipating maybe some worsening conditions, or where it's going to be wet and dry, where it may be hot or cold based on the information coming from the Climate Prediction Center. So again, we started back in 1999, and Mark showed it really well that the map has changed a lot. From back to where we started, again, 5 indicators. 5 indicators that were coming out each week that the authors could wrap themselves around and try to do a drought analysis. That's what we were using in '99. That's evolved tremendously with GIS, and we've had groups come to us and say, hey, I think our data is going to be very helpful in the Drought Monitor process. What can we do to have you all look at that and use it in the weekly analysis? And it isn't a straightforward process. We don't automatically take a new product and say, hey, we're going to use this, even though we don't know anything about it. So typically as new products come on board, we'll vet them behind the scenes as the authors. Some of this will go out in front of the drought community as well. But then we also see how they perform. And after some time and some review period, then we're going to say, yes, I think this is a good opportunity to bring in this new tool, this new data set. And that's part of this process. Again, these maps have come out weekly. I think with some pride, we're kind of like the mail service. We don't miss anything for earthquakes and blizzards in DC or weather events. All of us authors have a backup. And so if something happens out in DC and one of Mark's personnel are doing the map, they can say, hey, we're not going to be able to get into work the rest of the week. Can someone else pick this up for us? And one of the other shops will say, yeah, we can finish the map this week. So we have had this redundancy built in that every Thursday there will be a map. And everyone is expecting that map. It gets released at the same time. If it doesn't, my phone starts ringing, my email starts blowing up, I know there's a problem. Usually it's just a technical issue, but we get that map out every week. On weeks where there's a holiday, it may come out early, like Thanksgiving week. No one wants to be around on Thursday to put the map out. We'll put it out on Wednesday. But regardless, there is a weekly map going back every week to 1999. So we talked about the different material that we're trying to show on this map. So we have drought impact types. You're always wondering what these letters are on the map. We have short and long-term drought that we're trying to show. Some places it's a combination of both short and long-term. We have these different drought intensities. I'm going to get into that and what those mean. And we also say again that these are broad-scale conditions. Yes, as we've gotten better data and we're able to drill into these areas more locally, we still know that we can't get down to that farm or ranch scale, and wherever we draw the line, there's always going to be someone on the other side of that line. And so we do the best that we can with the data available, and we're a big data user. We don't produce any of the data that goes into this, but we definitely are bringing it in from all the different groups that do. So we have 5 levels that are being shown on the map. 4 of them are considered drought and 1 of them is not. And so a lot of times we will hear people say, well, I saw that yellow on the map, we're in drought. And really we're not showing the abnormally dry conditions as being in drought. That is a warning. Either you're getting dry, we're recognizing that dryness, or you may be going into a drought, or you maybe are improving from a drought. That, hey, we're recognizing that there has been moisture, we're seeing impacts improve, but we're still seeing some things that are not quite right yet. So we may show abnormally dry when you're coming out of the drought as well. And then we have the 4 drought intensity categories, from moderate drought, severe drought, extreme drought, exceptional drought. These are the DX levels, as we call them. And I'm going to break that down even further for you for these 4 drought intensities compared to the one that is not. So we have these tools that, through GIS, we're able to show these different regions. One of the newer efforts has been, let's show the USDA Climate Hub regions. But even within this region, you can get into different watersheds, you can get into state level maps, you can get county level data. The ability to do all this work in GIS has allowed us to provide all these different statistics that so many people are relying on for decision making, program applications, etc. So this is the map from last week. We just got it updated this morning. So at that time, this was saying that in this region, 65% of that region is in drought. 76% of the region was abnormally dry or worse. And we actually had about 4% of the region being in exceptional drought. And I'm going to talk about, again, what these categories mean. The change maps have been a great addition. This allows us to pull up any of these different time frames that I show here on the left and compare what the drought monitor looked like from the current period back to that period. So just for this example, I did a 3-month change map. And we can definitely see in the yellows and oranges and browns, that's showing where drought has gotten worse during that 3 months. In the greens and blues, that's showing where drought has improved during that time frame. And so these change maps allow you to quickly, again, 1 week, 4 week, 8, 12, 24, 1 year, calendar year, or water year, you can pull up those different time scales and see, again, this 3-month example we showed where that those heavy rains went across southeast Oklahoma and northeast Texas, where we've actually shown improvement. But then again, some of these areas, that's a 3-class degradation over the last 3 months as this drought has developed during the late winter, early parts of spring. So the change maps are one of the tools I use quite a bit when answering questions that people bring up. So with the Drought Monitor, we do have some objectives that all the authors try to incorporate into their analysis. And I'm just going to go through these real quick. Assessment of current conditions and current impacts. We're not projecting this out forward. We're not doing a forecast with this. It's showing at this point in time, this is the snapshot of drought across the country. The Drought Monitor is not a model. As we've described this process to you, we're not taking all these data and putting them into a formula or an algorithm, and that formula is spitting out the map. What the authors do is we take the previous week's map, We do the analysis with all the different data. We're bringing it right into our project with overlays, and we can see it in the background. And then we're manually adjusting those lines based on not only the data, but also through the coordination of an email listserv, the drought experts across the country who are validating the data and also providing information on impacts or problems in their region. The Drought Monitor is not interpreting just precipitation. I've had a great deal of calls over the last several years that, hey, it's rained in my county, it's rained in our region, and I don't think your map is showing that. And there are many products that are coming out through the Weather Service and others that show the precipitation, where it's above normal, where it's below normal, where it's occurred. And the Drought Monitor is using that data, but we're not trying to replicate that. Yes, precipitation is one of the most important pieces of data that we look at in putting the map together, but it's not just precipitation by itself. We're incorporating a lot of other data and information. It's not a forecast or a drought declaration. Only a state's governor can declare a drought, and they may use the map to assist that decision making, but this is not an official declaration of any kind. We talked about the impacts already. That local expert input. So when we started this process, an email list developed, and as Mark said, he got about 24 people to start in that initial stages of the Drought Monitor. And over time that has grown. And I'm going to show some other information on that over time, but these are the folks that, I can be in Lincoln, I can be drawing the map, but everyone in this room knows their backyard better than me. They know that, even though it's dry, this may not really be drought because this is what we typically see this time of year. Or yes, it's dry to the point that we're seeing X, Y, and Z happening. We got to do something about it, and the data really isn't matching up well with our area. Or vice versa. The data may be showing conditions as being quite droughty, but local experts are saying, we really haven't seen any problems quite yet, so we probably don't need to ramp that intensity level up yet, but we need to really pay attention and start seeing what does develop. So that's where those local experts come into play. And yes, they're showing us what their knowledge is of drought in their region, which is very helpful when you're covering the entire country. As an author, I have to be as objective as possible. I have this convergence of evidence approach where we start out very broad and we narrow it down into what we show on the map. I tried to relate it to a law trial. We put all the evidence out in front of you. At the end of the day, what does that converge to? What's the answer from that? And that's how the Drought Monitor comes about. We don't get any bonus or extra pay or any pay if we show more or less drought on the map. But my goal as an author is, if any one of you calls me up when I've done the map, I need to be able to explain exactly what I did, why the map looks the way it does, and I need to support it with data. I just can't say, well, it was dry. That doesn't help anyone. We need to be scientific about this, so when different drought periods occur, we can compare them equally and equivalently as we do this process. So again, this goes into that idea that many types of data are analyzed, but we just don't focus on a single piece of data. We try to look at everything, but we don't, in looking at everything, we don't let, again, one piece of the information or one piece of that pie drive the depiction. Multiple indicators and many types of information are part of the analysis. Again, as data has become more available to us, we're bringing this into the process and we're using it. And again, the impacts are the ground truthing mechanism. And the impacts are so important through this process because 12 years ago, the NDMC came up with a tool to start logging those impacts, and Mark's going to talk about it in the next talk. But we really haven't had this fundamental way of capturing drought-related impacts into some kind of archive. All the weather data and the climate data, we can go back 100, 110 years in some instances, but for impacts, it's really challenging to find that information, and that's where those local experts talking about those impacts is important to the process of making the map. So let's get into the drought intensity levels and the percentile ranking methodology that we use. So for each one of the drought intensity levels, it correlates to a specific percentile ranking level. What that means is we heard about the different varying periods of record of different data that we're using. Some may be only 15 years, some may be 100 years, some may be somewhere in between. But what we do with this methodology, and this is what the entire Drought Monitor is based off of, is we take those data and we rank them from the driest reading to the wettest reading, or lowest value to the highest value. Compare the current data to where that historical ranking is, and that tells us what category of drought is showing up. So what that means is if we have data and we rank them, the 21st to 30th driest or lowest readings are going to be that abnormally dry ranking. As we get to the 11th to 20th percentile, we get into drought. So that's saying 11 to 20th percentile, about a 1 in 5 type of event, 1 in 5 years. As we get to severe drought, the 6th to 10th percentile, or about a 1 in 10 year event. Extreme drought, the 3 to 5th percentile. Exceptional drought, the 1st to 2nd percentile. And those are the tails of the dry distribution. So we know that we can compare current data to historical, and this is how we do this. The advantages of percentiles is it can be applied to any parameter that we're using in this drought analysis. If it's 100 years, sure, you're going to have more occurrences possible when you compare your current data to those different categories. But regardless of the period of record, we can apply this methodology. It puts drought into a historical perspective as well. So when I see something that's falling in the 6th to 10th percentile, that's telling me, this is getting to be one of those rare events that I'm really focused on and showing on the drought map. So how are these percentiles? This is just a quick and easy way of getting a visual description of what they look like. So here's 100 years of precipitation data. The wettest years are shown on top, the driest years on the bottom. So we have the wettest year of 39 inches, the driest year of just over 11.5 inches. So that's our 100 years of data for, this is actually a location in central Nebraska. So when we start looking at these percentiles, so these 2 years, if I'm comparing my current data, if I was considering D4 exceptional drought, my current data would have to fall into those first 2 years. If I'm thinking D3, again, I'm only talking D3 or worse is 5 of these 100 years for this particular variable. When I get to D2, I'm picking up 5 more years. So to be in D2, D3, or D4, I'm only talking, my current data has to be worse than these top 10 years based on 100 years of record. To get on the map as drought, we pick up 10 more years. So moderate drought are these 11th through 20th percentile. And just to show up on the map, we need to pick up 10 more years. So as you're seeing, in 100 years of record, the vast majority of those years are going to be considered normal. They're not even going to show up on the Drought Monitor map. Just to show up on the map, we're talking about those 30 driest occurrences out of this 100 years of record. So if I'm looking at today's data and I'm comparing it to this record for this particular variable, just to get on the map as drought, I got to be in these top 20 events. So again, we can apply this methodology to any of the variables we use, and it's what we do. And these percentiles tell us a lot. It just doesn't tell us the percent of normal precipitation. It's taking that precipitation and putting it into a historical perspective, meaning that we can do a better job of comparing current conditions to historical events. And so we have a way of pulling all these Drought Monitor data together. So the top time series is the Arkansas, white and red river basin. And then down below is the Southern Plains from 2010 to 2015. We can see that over time droughts come and go. There's periods where there's no drought. There's periods where drought is pretty intense or severe. And so this is the top ones for the entire record of the Drought Monitor, all 18 years up to this point. And this is just a subset of a drought situation that we had here in the Southern Plains, where we can see that even during those very record-setting drought years of 2011 going into 12 and 13, that drought just wasn't stagnant, that we did see some easing of drought and then it got worse, and it just wasn't, hey, we hit drought and it stayed there. That there is some changes over time, and that's what we're trying to reflect in the Drought Monitor. So how is all this done? Talked a lot about some of this already, but I'm going to dig into this a little bit more. So these are the Drought Monitor authors. We have 2 authors at Mark Brusberg's shop in Washington, D.C. in the Office of the Chief Economist with USDA. We have 3 authors at the Climate Prediction Center in Washington, D.C. We have 3 authors at the National Center for Environmental Information in Western North Carolina in Asheville. We have 2 authors in Lincoln right now, and we're training a 3rd to get rolled into the rotation next year. And we have a Western author out at the Desert Research Institute in Reno, Nevada. So all these authors must come from a national or regional center. Doesn't need to be governmental, it can be academia. And we're all volunteers. We don't get hired on as Drought Monitor authors, but as part of our work, we also all have other duties that we do as well. So the data that goes into the Drought Monitor. We've talked a lot about how we slice and dice the data to get it into the map, but these categories are the main areas that we typically are looking at. So we're looking at, I'll start at the 12 o'clock location, the drought indices. So we're still using the Palmer. Even though the Palmer has went away as a triggering mechanism, we're still bringing in that data and we're using the Palmer and various other drought indices in the making of the map each week. Soil moisture. We have states that have their own mesonetworks that measure actual soil moisture. We have soil moisture models that have been developed for the country. There's efforts going on now to combine that in situ data from mesonetworks and other networks into a national soil moisture network that's getting close to getting off the ground. So we're using soil moisture. It's a great indicator for those quicker developing droughts, the agricultural, meteorological types of drought. Stream flow and reservoir data. Most of that data for reservoirs is done at a state level. It'd be a great idea if we had a national repository of all the different reservoir data, but we can look at it at a state-by-state basis. But stream flow data does come from USGS on a national level. We do use the 7, 14-day, 28-day stream flow data in the analysis. It's actually one of the first 5 that was available to us when the Drought Monitor started. Remote sensing is where this is really taking off. And the advent of the different satellite platforms and scientists taking these data and trying to measure things such as evapotranspiration, looking at relative humidity or atmospheric moisture. We're using it to look at vegetation. We're also starting to take climatic data along with satellite data and combining them to get a better feel. Well, is the vegetation not doing well because of climate or drought, or is vegetation doing poorly because of disease or frost or other impacts that could be happening? I think in the next 10 or 15 years, as we see the Drought Monitor keep evolving and going forward, and probably through my career, remote sensing is going to be where we see a lot more of these tools become available to us. Not only do they cover the entire country, but they cover it at a very fine resolution. We can really get down to that ranch or farm scale that many people are asking us to try and get. Expert local input and impacts. Again, we need more of these folks. Started at 25, we're out to about 450. There's opportunities for people to become involved in that process. Here in the state of Texas, the State Climate Office and John Nielsen Gammon has a coordinated weekly call. If you want to participate in that call, I can get you in touch with John. He's always looking for more information from around the state. He then takes that information and pushes it up to the Drought Monitor authors so we can incorporate changes for Texas into our analysis. There's also opportunities to be involved on the bigger Drought Monitor email list. I think all of you in this room could have an interest in doing so, and I'm going to use this as my recruiting moment. If you're interested in becoming part of that larger 450 plus email list server, there is a lot of email that goes through that, but we're always looking for more field level people participating in that process. Please see me today if you are, or capture my email at the end and we can get you set up with that. Precipitation and snow, again, drought is a lack of precipitation. In the west, we're looking at snowfall. Those are key indicators. We're not just looking at where it rained, but how much it rained. We're comparing it to historical averages and seeing, is this dryness really dry, or is this, are we really always dry in December and January? But then again, even during those dry periods, you can have droughts develop because Mark said it great. You can have droughts in the desert. You can have droughts develop during times when your dryness is typical for that time of year. It's just how atypical has that dryness been. So through all this, we started with 5. We're up to using 40 to 50 unique indicators in any given week that the authors are bringing in. It's a lot of data we're pushing through our desk in the matter of a couple days to put these maps out each week. So again, some of the data I talked about, again, during the growing season, we may have some specific crop indices that we're looking at, such as the crop moisture index or satellite health vegetation index. We've developed some newer tools that I'm going to talk about here in another slide. And out in the western U.S., we have some specific tools that make sense out west with the Swazi and reservoir levels and the snow-tail data and that. So what my point of showing this is not all parts of the country are created equally or treated equally. There are specific data sets that we are using in different parts of the country that make sense for those areas that maybe don't make sense to other areas. And again, here's this idea of emerging satellite-based observations and products. And we've come a long way in a short period of time. I think technology and computing power has allowed us to do a lot more with these data. When you get into these high-resolution data sets, it does take a lot of computing power to process them. And we're getting better at that. We're also using data mining techniques and machine learning techniques that as you throw these larger data sets into these computers, they can start finding patterns. And they can start drawing our eyes to particular signals coming out of these data. And what the satellite data is really trying to do is we're looking at, again, talked about evapotranspiration and vegetation. We're also able to use satellites to see where it rained and didn't rain. We can look at snow cover, we can look at soil moisture. There's other opportunities out there with satellites, and groups like NASA are constantly pushing scientists to that threshold of developing more. Some of these examples are these tools shown across the bottom. These are all satellite-based tools. ESI, or the Evaporative Stress Index, the Quick Drought Response Index, again, trying to incorporate these rapidly developing drought signals in a time scale that we can use and utilize in the Drought Monitor. The Evaporative Demand Drought Index, the EDDI, again, it's looking more at that total water cycle for a region. Gray soil moisture is coming from a satellite. It's fairly coarse, but it still has some utility, and they are getting that resolution better. And VegDry is incorporating climate data as well as satellite data to show the drought signal is based on climate data, not just, like I said, disease or infestation or other variables. So this regional and local feedback into the process. We talked about the forums. It's good to get together and get feedback. We don't want to do this in a vacuum where we think we're doing everything correctly, but we want to get that feedback from users. And we want to know, hey, can you guys do this? Is it possible to show these types of occurrences? Or can you use this data set? That feedback is invaluable to evolving the Drought Monitor and keep it continually improving and updating as data has allowed us to do. We incorporate, Mark talked about this, all the different partners that become part of this process. And I think you've probably heard me say that close to a dozen times now. I don't really talk about the map. I really talk about the process of how we get to that map. I think, to me, that's the most important work I do. We talk about the NIDIS dues, these different regional projects with the climate hubs and NIDIS. And like I mentioned, some of the states, and Texas is one of them, they've developed state drought task force that they coordinate their effort to the Drought Monitor author each week, which makes my job easier, but it also gives me points of contact that if I have a question, I can call up John and College Station and say, hey, what's going on in the Texas Panhandle? I'm not seeing what you're seeing, or let's talk about it some more. And so it really helped, again, 40 to 50 indicators in about 2.5 days worth of work for the entire country. I don't have the luxury to really focus on one area for too long. I got to really keep moving. I got to use the technology in front of me to do the analysis for the entire country. So how can you participate? This email list server is probably the key component of getting that field network involved in the process. So as you see, this was as of last August. Majority of these people are falling under the NOAA umbrella, Weather Service, Climate Prediction Center. The next big chunk is in academia, places like the University of Nebraska and University of Texas A&M, other places that have people, their state climate offices may be at a university. USGS is a smaller number. State government is about 5%. And USDA, we only have about 24 out of the full listserv associated with USDA. I think we have a large opportunity to grow that number, getting the field level people involved in this process. And it may take some time to really get your feet wet. You may lurk for a little bit, just see the types of discussions that go on, but then you may get comfortable and say, hey, I can help, I can provide information. And that's all we ask of these people. Again, they're all volunteers as well, but they validate the data and they really give us a local perspective when we're trying to identify drought in a particular region. So here's that distribution across the country. This was last August. So down here in Texas, we have almost 30 people. Oklahoma, 9. New Mexico, 6. 442 registered as of March 2018. So that number continues to grow. Last August, we were at 414, so we're about 30 more. I'd like to see that number continue to grow. These people are invaluable to the process. We also know that that local perspective not only helps to validate the data, but it does give some good continuity to the map when we can have people from New Mexico, Texas, Oklahoma all talking and they're saying, yeah, we agree that this is what it should look like. And I don't have to fight that battle of showing where those lines go when we can get the people discussing it through an email listserv. The examples of decision making based on the Drought Monitor, we're going to talk about those later. We've mentioned the big ones, USDA as well as IRS, but many other groups are using this as well. We have started doing these maps in Spanish. Through Mark Grusberg's group, we thought this was a good effort for some of our Spanish-speaking folks, and so we do come out with the national and regional maps in Spanish each week, and you can grab those right off of the Drought Monitor webpage. It says in Espanol on that last tab. So what's next? We're going to continue to work with partners on data sets and availability. As we've seen through the evolution of the Drought Monitor, 5 indices, inputs, all the way up to 40 to 50 now. I'm guessing at some point there could be a top limit to that, but technology has allowed us to incorporate that data up to this point. We're going to transition into an Esri-based portal for the development of the weekly map. Right now, each of the authors brings all that data into their computing systems at their shops. We're going to try and do this through an Esri online system where all those data can be brought so everyone can see them. And we can also bring that email list server to that portal as well, where it would be treated more like a chat forum where you would be identified, but you could provide your comments. Hey, Texas Panhandle, we've been drier than dry and we need to see drought intensify. Here's my data, here's my reasoning. That's all going to be done through that portal. We've developed some drought tutorials. I think that this is very timely, as these tutorials online answer some of these same questions that I've went through today in a learning platform where anyone can go in at their own time and go through this tutorial. Hopefully they're getting better informed on what the Drought Monitor is as well as the process. We're going to transition to these objective blends based on gridded data. Hopefully within the next year that will be happening. Ideally, we're going to be doing this before the end of the calendar year in a beta version. And what these objective blends are is it's taking multiple data sets and showing what the data itself, if we blended the data, this is kind of that model, the first guess of what we can do with the data. Again, we have to choose what the inputs are and what they're weighted, but technology can allow us to do a lot with those, and it will draw our eyes to areas that maybe the map isn't showing, and so maybe picking up those hot spots. We're developing potential impacts tables for each state. For those of you that are familiar with the Drought Monitor, we have some very broad general impacts associated with each of the drought intensity levels. What these tables will be is for each state, based off of data that we've collected over the years, it will say, hey, through the history of drought in your state going back to 2005, these were the impacts that showed up as these drought intensities were showing up. So it's going to be very useful to have that more dialed into each individual state. We talked about expanding the Drought Monitor to the U.S. Affiliated possessions in the Virgin Islands and out in the Pacific. They're covered under Farm Bill programs as well, and they do have drought, so we need to get that effort going. We do have a Drought Monitor brochure. I had copies in back for everyone. Again, this is a great handout for those that they may not really know exactly what's going on with the Drought Monitor, but in hopefully 2 pages in this trifold, we can answer some of those questions along with the tutorial. And I want to recognize our partners, and the cartoon says it's nothing to be afraid of, it's called rain. I think we've all been in those situations over the last few years. And I will put up my contact information and take any quick questions. Thank you.
I'll start with a question of my own. Show of hands, how many were aware that the Drought Monitor is available in Spanish? Wow. Okay. So this is that's a couple, but certainly an awareness, socialization effort that those of us in the climate services business need to undertake. That's excellent. So, questions about how the Drought Monitor gets put together every week, the inputs, the process, participation.
I do want to follow up on Brian's comment. We have tried for years to beef up that 6% USDA participation on the listserv. I mean, agriculture is the first impact felt typically at droughts, and we need more. We need more of your input from the field guys.
I'd like to make a comment. We love the summary at the Groundwater District. Our role is to disseminate this information, and so we've been visiting it and have gotten like our local city to use the U.S. Drought Monitor as its trigger for conservation and education purposes. And so when we stumbled across the summary, we really like it. I think it is a go-to compact thing. So your efforts to develop that are
I think a lot of times that summary gets overlooked and the map gets the attention, but there is a lot of good information in that summary as to why the map looks the way it does. So
especially
that's
that
great.
That
Regional and local assessment. I appreciate that comment. Yes.
I was going to say just before Joey jumps in. So, we all like to accrue kudos and accolades, right, in our own job. Do you guys like to get those sorts of testimonials from the field?
Absolutely.
Yeah. Okay.
Absolutely.
So please send that in.
And also on the summary is also being translated each week into Spanish as well. So along with the Spanish map, that summary that goes with the map is in Spanish each week too.
You were saying how you were starting to rely more on remote sensing, and I was wondering how much ground truth is going on. Specifically, I was wondering about some of these private corporations are starting to use remotely sensed precipitation data to get these really high resolution. It's raining on a farmer's quarter section or something like that. How reliable do you think that is?
Now I'm most familiar with what the Weather Service and and River Forecast Centers do, where they're taking mainly the radar beam, but they do in instances bring in the satellite data along with the data points on the ground to calibrate that. So we do know there are parts of the country it works really well. You start getting into terrain or there's areas where those radar beams don't reach out as far, that data can become a little more skeptical. But knowing that we have the ability to fill in some of those gaps using that data, especially for precip, I think I use more of the radar base than the satellite. But in some places, the satellite data such as chirps, and that, especially at a global scale, it's being used and people have had pretty good success with it. Validating it, that group does go through their checks and balances. And just like any tool that we would start incorporating, we're going to vet it for quite a while before we would wholesale bring it into our production cycle.
Yeah, you said that you use historical data on, like you had an example there of the 100 years there in Nebraska. Does that baseline change every year as you go?
Yeah.
Yes.
So if it changes every year, say 20, 30 years from now, your drought categories may change in that particular area.
That's exactly right. Your ranking, you know, especially think about where we've been in the last 8 years since 2010 here in this part of Texas. You start getting that data and it's shifting that whole distribution. Because the droughts of the 50s and maybe the drought of the 30s, they get pushed down that list. So you're exactly right. As every area continues forward, that ranking will change. So to have a map that looked one way today, D3 may be D2 in 20 years.
It goes to your question, the gentleman from New Mexico, that if you keep seeing these sort of droughts stack up, if let's say this year is the worst, comes on the first little raindrop in the bottom left, then the last one you had bumps down to number 2. And if that keeps happening over a 10, 15, 20 year period, that's changing that distribution. So you're right, that map is different 20 years from now, is taking those changes into account. And the thing it doesn't take into account well enough, at least from my opinion, working with on the social side of it as well, is vulnerability and risk. More straws in the drink, growing populations, strain on the water resources. Might only take a D2 drought to have impacts like a D4 in the 50s. So there's a fluid dynamic there that's still a little beyond the grasp of our map that we need to keep in mind that comes into the water supply and water scarcity issue.
Speaking of New Mexico, are any of you three familiar with the process for the drought monitor input that the state climatologist runs in New Mexico?
I sit on the DMWG.
Excellent.
That's it. Dave Dubois.
Yeah, I'm the FSA representative
Okay.
on our DMWG. So Royce and Dave.
Yep, Royce and Dave kind of ring that together.
Yeah, they're trying to coordinate with us, and they've started asking us from FSA if we can start looking at ground truthing when we're looking at to try to get our producers to either give us information so we can kind of look at just hands-on data or hands-on like stuff so they can just kind of look at it.
And Mark, that's going to kind of evolve into what Mark's going to talk about next with the impacts and impact gathering and reporting. So we're going to cover that here in the next section.
Why don't we go ahead and make it?
Go right.
Yeah, and again,